First, mass system. In last class, we have used mainly Cartesian coordinate system. But today, we will just try to use different coordinate system, mainly polar coordinate and spherical polar coordinate. So let's try to go for a calculating moment of inertia tensor for semicircular disk. So suppose this is your semicircular disk. So my drawing is not very good. This is my origin. Origin is very important, okay? This is my origin. And this is our radius. You can say this is your radius. And mass of this particular semicircular disk is all about m. So this is your mass. So what we have to do, we have to calculate the moment of inertia tensor for this particular system. This is in x direction and this is in xy plane. So obviously, this is again two-dimensional system. So you can see we can write the moment of inertia tensor very efficiently. So always start with the Cartesian coordinate. Don't worry. First start with the Cartesian coordinate, then see the symmetry, then try to see which coordinate system will be used very nicely. And I will also tell you what is meaning of which coordinate system will fit nicely. इसका मतलब क्या है वो जरा समझेंगे हम लोग इस प्रॉब्लम को करते समय. Okay. First, let's try to calculate Ixx. What is formula of Ixx? What is formula of Ixx?
Sir, integral
dm y square plus z square. This is your Ixx. Okay, good. Now z is equal to 0 because it is in xy plane. So I can put z is equal to 0. So what will be Ixx? Ixx is equal to dm y square. Everyone is comfortable? And what is my dm? M upon pi r square upon 2. This is density and this is obviously surface. This is mass by area. Okay. So this is sigma. And this can be written as dm by dx into dy. Everyone is comfortable?
Yes, sir.
Okay. So what will be my dm? My dm will be 2m upon pi r square dx into dy. Now look at what is the greatest challenge into this particular problem. So what we have 2m by pi r square and we have dx here and we have y square dy. Now anyone can tell me from where to where this dx will go and how this y will go?
Sir, dx will go from minus r to plus r. And y will go from 0 to under root r.
That is very good. So it will go from minus r to plus r and y will go from 0 to root under r square minus x square, isn't it?
Yes, sir.
Because I have circular thing x square plus y square is equal to r square. So I can write y is equal to r square minus x square root under. So this is absolutely correct. This is not wrong. But look at what is real challenge. The real challenge is that when we are going to integrate it, then this, when we are going to integrate y, I have to write y as a function of x because I have equation of constraint, something like x square plus y square is equal to r square. This will make the thing little bit lengthy. You can solve it with this method also. Don't worry, you can easily solve it. But obviously, if you have different mathematical tool, then obviously you can solve it in a very efficient manner. So efficiency is the key for the coordinate transformation. Now, if I am going to transform this whole thing into a polar coordinate, then what will happen? अगर मैं सारे चीज को ट्रांसफॉर्म कर देता हूं in a polar coordinate, then I can write m upon pi r square or 2m upon pi r square is equal to dm dx into dy, and that value is equal to dm, and that I can write r dr d theta. लिख सकते ना?
Yes,
And
sir.
what will be my dm? My dm is equal to 2m upon pi r square r dr d theta. Dx into dy can be written at r dr d theta easily. You know, with the help of Jacobian, with the help of coordinate transformation, with the help of geometry, you can easily write this particular thing. Now look at what will happen when I will use this thing. Then what is y here? I can take theta from the x-axis. Then what is your y?
R sin theta.
R sin theta. So y will be something like, sorry, small r sin theta. I can take any elemental mass. Okay, I can take any elemental mass, and at the r distance, and dr and r sin theta is something like this. Okay, so you can take something like this type of elemental mass. Okay, this will be d theta, this will be theta, this will be dr, this will be r d theta, isn't it? You remember this type of configuration you are just using, isn't it? So now if we are going to transform it, then look at how easily we can solve it. So what will happen? I can write dm as 2m pi r square, and what is y square? That is r square sin square theta, and in spite of dx into dy, I have to write r dr d theta. And now you can see, if we are going to integrate it, अगर हम इसे integrate कर रहे हैं, then what will happen? 2m upon pi r square is outside of integration, and what I have? R cube dr, from where to where? 0 to capital R. And next is what we have? Sin square theta d theta 0 to, what is this value? 0 to pi, isn't it? And now you can see the limit is constant now. Ho gaya na? The difference between this and this, you can see, if we are changing the coordinate, the difference is that here limit is itself a variable, but here we have choose our coordinate system so beautifully that my limit is constant. And obviously when constant limit is there, it will create a little problem. Everyone is comfortable with this argument?
The constant limit will create little.
Constant है ना, limit 0 से pi. This is constant, 0 to r. This is constant. But here your limit is 0 to r square minus x square,
Yes,
where
sir.
x is variable.
Yes, sir.
तो अपने आप वो तो इसके बाद इसको इंटीग्रेट करोगे, फिर तो x आएगा, तो इसी को इसके अंदर लेके जाना होगा ना.
Right, sir. Yes.
So यहाँ पर आप क्या देख रहे हो? You can just see this is variable. Your limit is variable itself, because your x and y both are variable, isn't it?
Yes, sir.
So this is very easy problem. This is just a two-dimensional system. But if you will go for three-dimensional system or little bit complicated system, then obviously it will create huge problem. And you are very lucky that your mass is also constant. Everyone is comfortable?
Yes, sir.
Yeah, na? So now you can see, I have changed my coordinate system such that this limit is going to constant. Now you can solve it. Solve करो, बताओ क्या होगा? 2m pi r square, and this value is equal to what? r4 by 4. What will be sin square theta d theta 0 to pi?
Pi by 2.
पक्का? Pi by 2.
Yes, sir.
Obviously. What is this value? कैसे solve करोगे sin square theta d theta? कैसे solve करोगे? How you will solve it?
Sir,
1
divide
minus cos 2 theta.
1 minus cos 2 theta करेंगे, and half is really outside. Cos 2 theta 0 to pi is 0.
0.
So you will get answer. And what is answer? m r square by 4. ऐसा आ रहा है क्या?
Yes, sir.
2 and 2 is cancel, pi and pi is cancel. And now you can try this question from this method also. Okay, it will obviously take little bit more time, and if you in the examination you will save 1 minute or half minute in each and every question, that will be very beneficial, isn't it?
Yes, sir.
Okay. So this is my IXX. Similarly, I can go for IYY. Yes. So everything will be remain same. So I am just removing the unnecessary part. So we are just removing this one. So let's try to go for IYY. What will be IYY? That will be dm x square. And when you will go for, and you will see this trick will also used into electromagnetic theory, electrostat, isn't it? कि जैसे ही चार्ज का डिस्ट्रीब्यूशन जैसा देखा उसी हिसाब से कोऑर्डिनेट को ट्रांसफॉर्म कर देगा, isn't it? है ना?
Yes, sir.
And everything is exactly same. Don't worry. Expression can be changed, but the way of mathematics is of the electrostat and even in magnetostat is exactly same. So try to combine the things such that you can see all your topic in a very holistic manner, but in a very compact manner. हॉलिस्टिकली पिक्चर देखना है, कॉन्सेप्ट हॉलिस्टिक रखना है, बट उसकी कैलकुलेशन जो होते हैं उसके कॉम्पैक्टनेस को आपको समझना है. आर यू गेटिंग माय पॉइंट? है ना? So I think Alok sir is also using the same concept, because we have discussed a lot that if we have make a combined concept such that the same concept can be used into mechanics, the same concept can be used into quantum mechanics, or the same concept can be used into EMT, it will be very beneficial for you, the coordinate transformation, isn't it?
Yes, sir.
है ना? Now, what will be this particular thing? What I will write? dm की वैल्यू क्या लिखे हम? 2m by pi r square, and x की वैल्यू क्या लिख दे? r cos square theta, and dx into dy की जगह पर क्या लिखे? r dr d theta. And
So,
now
R
r square is there. So you have again 2m pi r square integration of r cube dr 0 to capital R, and again we have cos square theta d theta 0 to pi. That value again cos square theta d theta. What will be 0 to pi? What will be that value?
pi by
Pi by 2. Pi by 2. Same thing. Okay. Again you will go for 1 minus sin 2 cos 2 theta type thing will be there. है ना? ऐसा ही कुछ होगा फिर से. So that value is equal to 2m pi r square r4 by 4 into pi by 2. And I think this value is equal to m r square by 4. Let's try to go for IYY. Sorry, IZZ. What will be IZZ? I can write this thing IXX plus IYY. लिख सकते?
Yes.
Why? Because the mass is distributed in a plane. So we can use perpendicular axis theorem. Okay. I assume that you know perpendicular axis theorem. I will discuss into next class all about this perpendicular axis theorem and all this thing. But let's try to solve it directly. Okay. Because it will give you a lot of intuition. X square plus y square. Again, what will be dm? 2m upon pi r square. And we have x square plus y square, r square cos square theta, r square sin square theta. You will remain only r square, isn't it? dr, sorry, r square into r dr 0 to capital R, and you will go for d theta 0 to 2 pi. What you will get?
mr square by 2.
Yeah, exactly. mr square by 2. If you will add it, both this thing IXX plus IYY, you will get exactly same thing. But I am using this particular first principle to calculate this particular thing. Isn't it? The distribution of mass is very important. The distribution of mass is absolutely important. Now, what will be IXZ? It should be 0.
Yes, sir.
Because mass is confined into xy plane. What will be yz? That should be also 0. But we have to calculate Ixy. So if we are going to calculate Ixy, what will be this particular thing? Minus dm x into y. Again dm will be same. एक बार आप dm निकाल लो, आपका सारा काम आसान हो जाएगा. What will be this particular dm? Minus 2m upon pi r square. What will be x? R cos
R cos
theta.
theta.
What will be y?
R sin theta.
So I have to use some space. यहां से करता हूं, है ना. एक बोर्ड पर पढ़ाना बहुत टफ है. Anyway, so this is Ixy minus 2m upon pi r square xy r square into r dr 0 to capital R, and you have sin theta cos theta d theta 0 to pi. समझ में आ रहा है ये कैसे किया है? हाँ या ना? x को क्या पुट किया? r cos theta. y को क्या पुट किया? r sin theta. So r स्क्वायर आ गया. ये r dr dm वाला है. And then sin theta cos theta d theta is there. What will be sin theta cos theta d theta 0 to pi?
0.
0. 2 से मल्टीप्लाई करो. That will be sin 2 theta. This will be 0. Oh my goodness. Look at this particular system. This is diagonal matrix. Isn't it?
Yes, sir.
All other component, all product of inertia is 0. You have only moment of inertia. And for this particular system, your moment of inertia is also principal moment of inertia. Isn't it? So आपने जो x axis, y axis, z axis इतना beautifully लिया है कि उससे आपका moment of inertia और principal moment of inertia दोनों क्या हो गया? Same हो गया. So in general, we have to take our origin in general, if it is possible. If it is not possible, then obviously you have to do all the calculation. But अगर मैं suppose करूं यहाँ origin ले लूं, so is that possible? It will be diagonal matrix?
No, sir.
No, it will be not a diagonal matrix. And you have to calculate each and everything in a very different way. So you are lucky that your distribution of mass is basically given as symmetric. Sorry, symmetric about origin. Clear here? So this type of problem can come into your exam. If it will come in your exam, don't be hesitate. Try to use your acumen of coordinate transformation of vectors. है ना, ये सारे vectors में आपने पढ़ा होगा, है कि नहीं?
Yes, sir.
चलो, let us try to go for a last one. And please, this is just a first level of problem. हम एक या दो क्लास लेंगे जिसमें कि प्रॉब्लम बिल्कुल ही मिक्स होगा, है ना? Everything will be there. So this is your basically hemisphere, solid hemisphere. You can take solid hemisphere. Okay, and origin is at the center. What you have to do? You have to just calculate IZZ. सारा calculate नहीं करना है. And you have tutorial also. In tutorial there are a lot of problems, so you can just practice it. Let's try to go for IZZ. So this is my x-axis. Obviously, this is my y. This is my z. What is IZZ?
dm x square plus y square.
Very good. dm x square plus y square. Okay, I can assume dm must be something like this. Okay, and this will be 3-dimensional dm, है ना? कुछ ऐसा dm होगा. Can anybody tell me what is x square plus y square?
R square.
R square, sir.
No.
R square sin square
R
theta.
square sin square.
This is r square sin square
square
theta.
theta.
Okay, that is mathematically you are 100% correct. But I just want to know qualitatively what is this particular thing, because I have to use this concept into next class.
Sir, how sin theta?
Perpendicular distance
Z
from
square
the
minus
z
R
axis.
square.
क्या बोल रहा है? कभी किसने z स्क्वायर माइनस क्या बोल रहा था?
X square plus Y square equal to Z square minus R square.
वो तो सबको पता है. ये क्या है? ये तो तुम यार ऐसा बात करते हो, हाँ?
Perpendicular distance from z axis.
Exactly. This is nothing but perpendicular distance from z axis. जो मास एलिमेंट है उसका परपेंडिकुलर डिस्टेंस z एक्सिस के साथ है. आर यू गेटिंग माय पॉइंट? इसका यूज हम नेक्स्ट क्लास में करेंगे. व्हाट इज डेफिनेशन ऑफ मोमेंट ऑफ इनर्शिया एक्चुअली? दैट इज dm into perpendicular distance square, isn't it? So this is
Yes.
nothing but the perpendicular distance square. Okay, that we will discuss into next class, don't worry. But very good answer, Puneet, very good. So this is nothing
Sir.
but the bolo.
Sir, how it is perpendicular distance from the mass?
You can just check it. अभी check कर लेते हैं, है ना?
Yes, sir.
So if we are going to for a spherical polar coordinate, which coordinate system is the best one?
Spherical polar.
A spherical polar coordinate, you know. So dm upon 4/3 pi r cube तो पूरे का होता है by 2, यही होगा ना? ठीक है, स्फीयर का यही होगा ना, हेमिस्फीयर का. मुझे सब याद नहीं रहता है, प्लीज आप इसमें हेल्प करो. ठीक है,
Yes, sir.
ओके. एंड दिस विल बी m by and this will be dm by what is this particular dx into dy into dz?
R square sin theta dr d theta d phi.
गजब. क्या कौन पीछे टीवी देख रहा है पुनीत? हाँ, दिस विल बी r स्क्वायर sin थीटा, है ना, dr d theta d phi, यही होगा ना? So what is this particular thing? So 6/4, so that is 3/2 na, 2 pi r cube 3m into r square sin theta dr d theta d phi is equal to dm. यही सबसे बड़ा चैलेंज है, इसके बाद तो कुछ भी नहीं है. dm लिख लिए तो सारा काम खत्म. उसी तरह से इलेक्ट्रोस्टैट में dq लिख लिए तो सारा काम खत्म, है या नहीं?
Yes, sir.
उसी तरह से मैग्नेटिज्म में DI लिख लिए तो सारा काम खत्म.
Yes, sir.
यस या नो?
Yes, sir.
Yes, sir.
उसी तरह से क्वांटम मैकेनिक्स में D रो लिख लिए तो सारा काम खत्म. Isn't it?
Yes, sir.
So everything is connected. Mathematics is beautifully connected. Concept is different, conclusion is different, but mathematics is very beautifully connected. Okay, so you can just look at this particular thing. Okay, now what is x square plus y square? बताओ, अभी किसने क्वेश्चन पूछा था सर ये परपेंडिकुलर डिस्टेंस कैसे है? नाम बताओ. एक्स स्क्वायर प्लस वाई स्क्वायर क्या होगा बताओ?
सर मैंने पूछा था सर.
हाँ, नाम क्या है तुम्हारा?
शिवेश.
सॉरी शिवेश. चलो शिवेश जी, ये क्या है बताओ? एक्स स्क्वायर प्लस वाई स्क्वायर को क्या लिखोगे? आर स्क्वायर
साइन स्क्वायर थीटा.
साइन स्क्वायर थीटा, बस यही है.
सर इसको जैसे x इक्वल्स टू r साइन थीटा कॉस फाई.
वेरी गुड. एक्स को क्या लिखोगे? आर
sin theta
साइन
cos
थीटा
phi.
कॉस फाई, वेरी गुड। वाई को क्या
Y equals
लिखोगे?
to r
आर,
sin theta sin phi.
वेरी गुड, साइन थीटा साइन फाई। अब बताओ ये क्या होगा?
तो r sin square theta sir.
वेरी गुड, आर साइन स्क्वायर थीटा कॉस स्क्वायर फाई प्लस साइन स्क्वायर फाई, क्या वैल्यू क्या हो
One
गया?
one one
वन
हो
हो
जाएगा।
गया, वेरी गुड। आर क्या है भाई, ये बताओ।
तो
दिस इज
समझ
योर आर,
गया सर, समझ गया सर।
समझ गया?
Yes
एंड
sir.
दिस इज योर थीटा, so this is perpendicular distance of this
R
one,
sin theta. Yes sir.
है ना?
Yes sir.
Very good. So this is your r sin theta. This is perpendicular distance. नहीं? ठीक है?
Yes sir. Yes sir.
Very good. So now you will just go for this. चलो फटाफट इसे कैलकुलेट करते हैं। कैलकुलेट करेंगे एंड कैलकुलेशन इज वेरी इंटरेस्टिंग। ठीक है, डीएम के जगह पर so क्या क्या बाहर ले लें? 3m अपॉन 2 पाई आर क्यूब इंटीग्रेशन आर वाला पार्ट के लिए क्या हो जाएगा? आर स्क्वायर साइन स्क्वायर थीटा यहां पर पुट करोगे, सो यू हैव r4, ठीक है ना, dr 0 टू कैपिटल आर। और साइन थीटा का वैल्यू क्या होगा? एक साइन थीटा यहां पर और दूसरा साइन स्क्वायर थीटा यहां पर, तो दैट वैल्यू इज व्हाट? साइन क्यूब थीटा डी थीटा। तीसरा क्या हो गया? डी फाई। चलो साइन थीटा की वैल्यू कहां से कहां जाएगी? पुनीत के अलावा, पुनीत नहीं बोलेगा, है ना? व्हाट इज वैल्यू ऑफ थीटा?
0 to pi.
0 टू
0 to pi.
लगेगी पिटाई तेज।
Five
क्या होगा? पाई बाई 2। दिस इज हेमिस्फेयर। 0 to pi when you will go for a sphere, isn't it? So that is 0 to pi by 2. What is d phi? 0 to 2 pi. 0 to 2 pi or 0 to pi?
2 pi.
2 pi. Whole rotation is there. You will see. एक एप्पल को काटो और नीचे से देखो, पूरा सर्कल है ना? एप्पल को बीच से कट करने के बाद नीचे पूरा सर्कल नजर आता है। Assume apple is spherical in shape. Huh?
Yes sir.
Yes. So this is one. Where is real challenge? सौरभ, रियल चैलेंज कहां पर है?
sin cube theta.
साइन क्यूब थीटा। वेरी गुड। कैसे इसे इंटीग्रेट करोगे?
सर
3
गामा
sin theta minus 4 sin.
चलो या तो आपको
2
गामा इंटीग्रल वगैरह कुछ पता है तो उसका यूज कर लो, अदरवाइज मैं इसको कुछ ऐसे यूज करूंगा। आई विल राइट साइन थीटा 1 माइनस कॉस स्क्वायर थीटा डी थीटा। तो दो इंटीग्रेशन हो गया, साइन थीटा डी थीटा माइनस साइन थीटा कॉस स्क्वायर थीटा डी थीटा। 0 टू पाई बाई 2, 0 टू पाई। अब यहां पर साइन थीटा को, सॉरी कॉस, क्या लिख रहा हूं मैं? हाँ, सो कॉस थीटा को आप क्या पुट कर लो? टी पुट कर लो, एंड साइन थीटा डी थीटा इज व्हाट? डी टी। सो इजिली आप सॉल्व कर सकते हो जाएगा सॉल्व। या तो फिर आप डिफरेंट टेक्निक भी यूज कर सकते हो। व्हाट विल बी आंसर? आंसर क्या होगा? दैट विल बी समथिंग लाइक 2/3। ओके, याद रखोगे। और 0 से पाई तक क्या होगा? 4/3। ओके, सो दिस विल बी this have to remember. देखो क्या आंसर आ रहा है, जस्ट चेक इट।
So 2/5 mr square.
सो दैट विल इज 3 से 3 कैंसिल हो गया, 2 पाई से 2 पाई कैंसिल हो गया। सो दिस विल बी 2/5 m r square. So this is your IZZ. I request you just go and do IXX, IYY, IXY, IXZ. Everything you can easily calculate. So now you can see how coordinate transformation is very interesting and very important for solving all this type of problem. ठीक है? So जहां पर जैसा सिमेट्री है उस सिमेट्री का आप यूज करो एंड बेसिकली चीजों को आप इजिली जा सकते हो।
सर आर का लिमिट हमने यहाँ पे -r to r क्यों नहीं लिया?
ये कौन, किसने, पहले अपना नाम बताओ तुम।
सर रूपाली।
रूपाली, क्यों नहीं लिया बताओ?
सर हमने पिछले क्वेश्चन में जब हम
पिछले क्वेश्चन में लिया था क्योंकि x की वैल्यू माइनस और वहां पर कहां लिया था मैंने -r2r, कहां लिया था मैंने, ये जरा मुझे बताओ तो। हाँ बताओ बताओ, लिया था कहां लिया था?
सर जब हम कार्टेशियन में कर रहे
कार्टेशियन में कर रहे थे, तो अभी किस में कर रहे हैं? कार्टेशियन में कर रहे हैं क्या?
नहीं सर, सॉरी सर, समझ आ गया सर, स्फेरिकल
वेरी गुड, समझना इंपॉर्टेंट है ना। मैं क्वेश्चन आपसे इसलिए दोबारा पूछता हूं, काउंटर क्वेश्चन, कि आप चीजों पर फोकस करो। आर यू गेटिंग माय पॉइंट?
यस सर।
जैसे स्फेरिकल पोलर में कन्वर्ट किया तो कहां से कहां जाएगा? 0 to R ना।
यस सर।
उसमें तो नेगेटिव का कोई मतलब ही नहीं है।
यस सर।
ठीक है, ये सारी चीज ध्यान रखोगे। गुड, वेरी गुड। यही अगर मैं dx dy dz में करता तो आपको लेना ही पड़ता है ना।
यस सर।
ठीक है, ओके। चलो, so I will just give you next 20 minutes, only 20 minutes, not more than that, for the center of mass. Okay, so we can just try to understand what is center of mass, what is basic definition of center of mass, and how we can calculate it. And in the next class we will go for moment of inertia, and after then we will go for rotational dynamics. Okay, so we will solve a lot of problems into rotational dynamics, lot of new problems actually. So what is center of mass? So you have, suppose you have this coordinate system, let's say x, y, z, and there is lot of masses are there, है ना? Let's say you have mass m1, mass m2, mass m3, and let's say mass mj, and every coordinate is connected from origin is rj. This will be r1, this will be r2, this will be r3. So in spite of using all this particular mass, there are a theoretical, I am not saying hypothetical, it is a theoretical point where all the masses can be concentrated. And that is actually some sort of average. Look at, so what is RCM? So R, and here is, there is one particular point that is, or one particular distance or one particular vector, that vector is known as what? RCM. So if I am talking about RCM, then what is your RCM? The RCM is defined as summation over mi ri by summation over mi. So if you are just going to, and what is this summation over mi? Is total mass, isn't it? Summation over mi is total mass. So you can write something like RCM is equal to summation over mi by into ri. So this thing can be written as, you can see this is something like average, isn't it? This is something like average. So on an average, you can say where is your masses are going to lie. So center of mass is a very important point, and it will always reduce your effort to solve the problem if you will try to use center of mass as your origin or something like this. And you can, and center of mass is also known as, and you can see this is m RCM is equal to summation over mi ri. So this is all about moment of mass. This is something kind of thing that you can write something like as a moment of mass. And if somehow you are just going to choose this center of mass as a origin, then you can easily make your life very simple. For example, let us try to go for one example from basically central force problem. So I am just taking this from your tutorials, and where we will use the concept of center of mass. Okay, look at what we are going to do. Just a minute. So you have two binary stars, S1 and S2, and whose mass is basically m and 2m. So one mass is m, another mass is 2m. Okay, these are two masses, and their distance between these two masses is, let's say, r, and they are rotating in a circular orbit about their center of mass, as a center of mass as their origin, or as their center. Are you getting my point?
Yes, sir.
So what will be velocity, what will be ratio of their velocity? Let's say this, its velocity is v1 and its velocity is v2. It has v1 and it is v2. So look at this particular problem, and you can assume, you can see how center of mass will help you to solve problem. So I can assume that this may be my center of mass, where this is your distance r1 and this is your distance r2. Let us assume this is my RCM, and this is my center of mass, and this mass is rotating in a circle, something like this, and this is also rotating in a circle, something like this, isn't it?
Yes, sir.
Okay. Now, and they are just rotating in a circle with a mutual gravitational force. So it is very important. And they are rotating in a circular orbit. So what will be condition of circular orbit? For, let's say, for first mass, m v1 square upon r1, or I can write m1 v1 square upon r1 must be equal to force. And what is the force between these 2 points?
G2m square upon capital R square.
Let's say m1 and m2, g m1 m2 upon r square. The centrifugal force is equal to external force. This is condition of circular orbit, isn't it?
Yes, sir.
And r is the distance between these 2 points. So they will always maintain a distance r, and they are just rotating in a circular orbit. So this is for the first particle. What about the second particle? बताइए क्या होगा?
Sir, m2 v2 square.
m2 v2 square upon r2 is equal to, again, g m1 m2 upon r square. Yes or no?
Yes, sir.
So now we can divide, and we have to find the ratio between v1 and v2. So if we are going to divide these two things, then what I will get? v1 square by v2 square. This m1 is cancelled. This m2 is cancelled. So r1 is, and this r square is also cancelled. So what will happen? This g is also cancelled. So what will happen? m2 by r1 by m1 by r2, isn't it? And I have the value of m2, I have value of m1. The whole thing is that what will be ratio between r1 and r2? If somehow I will get the ratio between r1 and r2, I will get answer. Everyone is comfortable?
Yes, sir.
And now look at how the center of mass is going to come into picture. So if you have this particular concept, what is your RCM? RCM is m1 r1 plus m2 r2 by m1 plus m2. यही होगा ना? And now I can choose RCM as my origin. क्या मैं चूज कर सकता हूं RCM को एक origin की तरह?
Yes, sir.
It's my choice. So I can choose RCM as an origin. Then look at what you will get. You will get M1 R1 is equal to minus M2 R2. And if I am talking about magnitude, so there is not any problem. So I can get R1 by R2 from here. है ना? नेगेटिव साइन का मतलब क्या है? नेगेटिव साइन का मतलब यह है कि एक अगर इस डायरेक्शन में जाएगा तो दूसरा अपोजिट डायरेक्शन में जाएगा. So this is all about this particular thing. So I can choose, and if it will be 0, it should be -1. So that I can easily put it here. So from here, in a term of magnitude, what you can do? You can just write R1 by R2 is equal to M2 by M1. And now you can put it here. You can have V1 square by V2 square is equal to M2 square by M1 square. And you can find V1 by V2 is equal to M2 by M1. Isn't it? So this type of question, when many body problem will come into picture. We have also seen the glimpse of when the two body problem can be converted into a single body problem. The center of mass is very important because it has some beautiful property. And we will see when we will go for conservation of momentum, the rotational dynamics and all about this thing, we have to calculate center of mass very efficiently. So obviously this is for the discrete mass. What will be center of mass for the continuous mass system?
Integration.
Obviously, we have to go for RCM is equal to nothing but DM, and obviously you will go for RI by summation over DM. And RI will be changed to R. And now this is vector quantity, so you can go for X separately, you can go for Y separately, you can go for Z separately, and you can easily calculate. Suppose if I want to go for XCM, what will be my XCM? DM X upon summation over DM. Isn't it? So again, what is the whole challenge when you are going to calculate what will be your center of mass?
So to express DM in form of X.
Obviously, that's how you are going to write DM. है ना? किस तरह से आप DM लिखते हो? Again, the same challenge is there. So same type of concept you are just going to use. Clear है ये?
Yes, sir.
Yes.
है ना? Everyone is comfortable? So let's try to go for one or two problem, and we will continue this topic into next class also with the obviously some problem with center of mass and some problem with your this particular thing. Basically moment of inertia, parallel axis and perpendicular axis. Okay. And in the for the JAM examination, this is very important topic. Every year you have at least one question. Okay. Chalo. Let's try to go for this one. So this is origin, and this is linear rod, and here is my origin. So, and it is given the linear density is something lambda naught into x. So we have to calculate center of mass of this particular rod, and length of rod is L. Don't worry. Length of rod is L. So you have to just calculate the center of mass for this one. So what will be center of mass? Only x-axis is there. So what will be XCM? DM into X by DM. Isn't it? Yes or no?
Yes, sir.
Yes. And what you will do? You will just write DM upon dx, this is linear density na, is equal to lambda. And now you can see this lambda is not variable, not constant, rather it is variable, isn't it? Now, what is your dm? Lambda naught x. So you can put your xcm as dm, and you can put lambda naught here. Sorry, xcm is basically, sorry, kya kar raha hu main, into dx. So you will just put x, this is this x, and dm, that will be lambda naught x dx. You will go from where to where?
0 to L.
0 to L. And again, you will just go for lambda naught x dx 0 to L. What will be answer?
2 by 3.
2 by
So
3.
that will be 2 by 3L. So this is your xcm. Very simple, straightforward. Isn't it?
Yes, sir.
Hannah, this is straightforward. Let's try to go for another problem. This is semicircular ring. This is just all our +2 problem, okay? So don't, if you know each and everything, so don't get overconfidence. If you don't know, so don't dishearten yourself also. Just try to learn or try to revise, okay? So this is my semicircular ring, not disc. This is semicircular ring. So we have to calculate the, basically, your center of mass. So what will be your xcm? This is your y. This is your x. What is your xcm? dm into x by dm. Yes or no?
Yes.
So what will be this?
0.
0. Why? Because exactly the same weight towards left, right, and same weight towards left. And even if you are not recognizing this symmetry, then also it is going to be 0. Look at how. How you will, what will be your dm? Now you have to convert each and everything into which coordinate system?
Spherical Cartesian, right?
Spherical.
Spherical. Why? This is ring. This is not a. This is ring.
Cartesian.
Cartesian coordinate, polar coordinate system, na? Here you have this as your length, r d theta, isn't it? This is theta, this is your d theta. You have to take this thing as r d theta. So this is linear. Your mass is linearly distributed along the line, along this particular curve, isn't it? This is not distributed in whole this place. So what is x? बताओ क्या होगा? R cos theta, isn't it?
Yes.
This is r cos theta, and from where to where you will go?
From
0 to pi. Yes or no?
Yes, sir.
Okay. So what will happen? R cos theta, this is your x, and what is your dm?
2m upon pi r square into r square sin theta.
2m pi r square.
Pi r no, m upon.
So dm is equal to dm upon dl, isn't it? What is this thing? This is dm upon dl. So that will be m upon
Pi r.
pi r. Okay, so this will be m upon pi r. This is your m upon pi r. What is dl? dm upon r d theta, isn't it?
Yes, sir.
Okay, so just put it here. What will happen? R cos theta, and you will just put, what is value of dm? M upon pi r into r d theta. Yes. And what is cos theta d theta 0 to pi? 0.
Yes, sir.
So this is your 0. Hoga. And you can also see the symmetry. The mass is distributed towards right and towards left exactly at the same proportion. So why this is symmetric about y-axis. So x center of mass must be 0. So why I can just see the symmetry and I can tell this is basically 0. But if you are not seeing the symmetry, then also you can calculate it. And now look at what will be your y CM. dm into y, and here is your dm. Is that it? This will be also 0?
No, sir.
No, this will not 0. Just you can calculate. So what is your dm? dm को क्या लिखेंगे बताओ? m upon pi r, and you will just go for r d theta. What is your y? R sin theta 0 to pi. And what is your dm here?
Capital M.
Capital M. Very good. If you will integrate it, you will get the mass m, because the mass is uniformly distributed. Don't worry. But if it will have some function of theta, then obviously neither xcm will 0 nor ycm will 0. है ना?
Yes, sir.
Okay. So this m and m will cancel. This r and r will cancel. And you can take r by pi, and you have sin theta d theta 0 to pi. What you will get? 2 na? This integration is 2. So this is 2r by pi. This is very famous question for mainly into the IIT-JAM question. And now you can see the masses are distributed into this particular curve. But where is your center of mass? Some point here. And this is some theoretical point. Okay? But that theoretical point has a lot of significance to solve the problem, to understand the system in a very holistic way. So here is my center of mass, exact at the y-axis, and the value of this is 2r by pi. And this is due to this distribution of mass. So distribution of mass is very important thing. Yes? Everyone is comfortable? So I will just give you one homework, and tomorrow I will complete it, and I will also complete moment of inertia in a very fast manner. Not very fast, same pace I will maintain. So let's just try to calculate the moment of inertia, sorry, the center of mass for semi-circular disk. Mass is m and radius is r. कर लोगे इसे homework?
Yes, sir.
Just try to do this thing ताकि कल थोड़ा फास्ट कर सके चीजों को. Tomorrow I will just use lot of technique to parallel axis theorem and perpendicular axis theorem. कुछ masses हटा देंगे तो क्या होगा, कुछ masses जोड़ देंगे तो क्या होगा. This type of problem is very interesting and we will try to solve it. Okay?
Yes, sir.
चलो. Just do practice. आपके बुकलेट में बहुत सारे क्वेश्चंस दिए हुए हैं. Just do practice and especially for IIT-JAM student. Okay? नेट स्टूडेंट जितना हो रहा है करते जाओ, but you have to focus on mainly Lagrangian, small oscillation, all this particular thing. But this type of question will come into your GATE exam, JEST exam, TIFR exam. So you have to just complete it. Okay? Chalo, thank you.
Thank you, sir.
Thank you, sir.